very much, and really welcome you all to my talk. And I understand this is like the last talk of the day for this track, so really appreciate you being here. So, okay, so thank you too to the organizing team and especially to Rustam. So really appreciate this opportunity to be here. So yeah, and let me know too in case I'm also monitoring my other the YouTube to kind of make sure that there are no specific comments asking me if you can't hear me and all that. So I'm assuming everybody can hear me. So okay, thank you, thank you, thank you. So my topic today is about exploring streaming platforms for MLOps. This Confer is a conference about primarily, right, about artificial intelligence, data science, machine learning, the cloud, and everything. And so even like when Rustam first kind of talked to me about the conference, I'm like, well, I'm not really exactly like machine learning. But the thing is, it's pretty amazing. I think we live in a world of such, like everything is kind of interconnected now. You can't just say, you exist on your own. A lot of times too, we're interdependent on each other. So likewise, right, in the computing world too, I'm primarily doing streaming. As you can see, my title is a streaming developer advocate, but I find that as such, we actually can find use cases, right, in ML ops, for example, that we can apply the techniques. And as such, not just, what I'm doing now, Apache Pulsar, which is what I'm going to be introduced to you about, but there are also, say, Kafka already in place, Google pops up, all of these, Amazon Kinesis. So all of these too. And I think it's such a fascinating topic area. So without further ado, let me start. So okay, let me go back to my, I can't get to my thing. Okay, here we go. So, okay, first of all, if you are interested in the slide deck, it can be accessed here. So this is the bit.ly link, but don't worry about it if you miss, because I'm going to be sharing this this bit.ly link too with the organizer here at Confer, so then you can get to it too afterwards in case you miss. Or if you really would like to have it now, you can post your question too on the YouTube chat, and then I can also be sharing with you there too. So, okay, so that's all. Let's go. So who is Mary? Who am I, right? So I'm a senior developer advocate at DataStax. I'm specifically too on the streaming advocacy team. We have a group of developer advocates, about maybe 7 or 8 of us, but 2 of us are on the streaming side. It's a bit of a newer venture at DataStax. And as you may know, if you are familiar with data, right, database, and DataStax is really the flagship is with their Cassandra and Apache Cassandra project. It's very much a company with open source technology, but we have our cloud, which is Astra DB, and it's essentially managed Cassandra on the cloud. So anyway, so I'm a senior developer advocate at DataStax, and we're again all about NoSQL, big data streaming, and the cloud platform, cloud native platform. And I was with the Java and WebSphere open source advocacy team at IBM previously for about 3.5 years. I'm based in Chicago. I'm also a Java champion and president and executive board member of the Chicago Java Users Group. I'm also co-organizers for a few IBM-sponsored meetup groups in Chicago that includes like data, cloud, and AI, Chicago Cloud, and IBM Cloud. And so, yeah, so I've been involved too with machine learning. Just very happy to be here again. My background I have been actually, previous to me becoming an advocate, I was a software engineer for about over 20 years in primarily Java. So I kind of get my hands into a lot of things. I understand too the pain of doing production, deployment, all of these things, not just doing design and development. So I certainly understand it. And so my topic is about ML ops. It's really more about, how do you get to the production stage, making it kind of real, right? Deployment, all of these things. So, and then on the left-hand side are how you can get a hold of me. All of these links, my Twitter, my LinkedIn, my Twitch. I have a weekly Twitch stream, and I have that information towards the end of my slide deck too. And then I also have my Discord server if you like to stay in touch or just ask questions at any time. Okay, let me okay, so this is just another, kind of a, what you call like a biography page from my company. Now, we all have this, and then we put in the logo. So I'm Java champion and all of these things, and CJUG and all of these. So Okay, so let me kind of go ahead. So today's agenda, I will start by talking a bit too about some basics about MLOps. Let's kind of all get to an understanding. You can tell me on the yeah, and hi. I see a Confer conference saying hi, hello. So if you're have any questions, please feel free to post it onto the chat on the YouTube chat. I can try to answer it if it's kind of quick answer. But other than that, I am going to be start with talking about MLOps, some challenges of MLOps, and then some basics about event streaming and distributed messaging, and why is it that it's relevant, right, for MLOps, for events, for distributed messaging. Just giving everybody a basic kind of introductory understanding. And then why, event streaming, and, why do we need it, and why is it for MLOps? And then some examples of streaming platforms that includes like Apache Kafka. And then I wanted to be spending a bit more time on Apache Pulsar because that's the platform that DataStax is supporting right now for streaming. So, and I believe that has a lot of benefits of using Apache Pulsar. So that's why I'm excited to be bringing to you this option if you're looking for a streaming platform for doing machine learning ops, operationalize your machine learning pipelines and all that. So here we go. Basics about MLOps. So what is MLOps? And this too, as you can see, I took it from the Towards Data Science, the Medium blog post, the series of blog posts. I thought this is very, very, very good of explaining it. And perhaps a lot of you have looked at it in the past already. So it describes that MLOps is a set of practices that combines machine learning, DevOps, and data engineering, which aims to deploy and maintain machine learning systems in production reliably and efficiently. So that, I think that sums up pretty good. So if you express that in like set theory, in math set theory, on the right hand side, machine learning, DevOps, and data engineering, that's the intersection point, right, of all three. That's MLOps. And I thought that's kind of a really great diagram that sums up, right? And a picture is worth 1,000 words. I think that explains it quite well. So that's that. And then challenges though in MLOps, let's take a look at it. So why can't DevOps solve the problem for MLOps? Like DevOps is also still not an old concept. It's still kind of relatively new, I say, right? It came out about 6-7 years ago, perhaps 2015. I remember I was working for a cell phone company. We were talking about DevOps. And so why can't DevOps, right, solve the problem from MLOps? So DevOps is primarily about the code, right? The code that essentially involves logic, right? The programs to drive the workflow. You want to kind of operationalize your systems into production, kind of drive the workflow. DevOps is mostly just about the procedure, the process. It's about the code. Whereas in MLOps, the code is carefully crafted in a controlled environment. Well, actually, I should kind of go back a little bit. So DevOps is about the code. When we talk about code, and code is always carefully crafted in a controlled development environment, perhaps too without concern for any data, right? So MLOps has in fact introduced a different set of challenges. So, and again, over here too, I highlighted that it has a different set of expectations. So let's take a look at it. MLOps is not just about code. It is also about the data. So if you kind of take a look at this diagram, it's really about data, on the left-hand side, data, and then the code, and then you do all of the training, right? Because the thing is too, is the algorithms isn't known until you have the data too. So there's code, but the code is kind of like preparing the data to be trained, right? It's kind of like your engine is kind of being trained as you speak, as the data comes along. And that kind of output it into a machine learning model, right? So that kind of then defines it, right? After it does all of the things. I've done a little bit of machine learning in the past too. It was actually a presentation I did with a Ukrainian, also a Java champion. We did it on training a bot to play a Pac-Man game, and we were just using like streaming to do it too. So I think that's why I feel is there's a lot of excitement about it. You're training the model, right? And so right now too, the model that we're all used to tends to be more synchronous, more batch processing type of kind of approach. But the thing is too, let's see, right? So this is kind of a bit of the challenges in here. So if you kind of take a look too first, right, into traditional software versus like AI and ML software. Traditional software, right, you scope the project, and then you develop the code, right? And you scope it and develop the code, pretty much is ready. You kind of test it a couple times, and then you're ready to go to production. For AI and ML kind of software, right? You scope the project, but yet, as in the previous example I was showing you, machine learning, and with kind of AI too in mind too, is about you develop the code. The code isn't sufficient because you also have to worry about the data. You're constantly ingesting data that coming into your pipeline, and you need to be, the code needs to be then dealing with this data, and then it's kind of essentially too, it sends over to generate a training model, and then it keeps going back. You probably start to deploy to production, but then at the same time too, the deploy to production too isn't ending, right? The part is that it's you constantly be dealing with data that's changing, and as you know, right, I think the word to use is entropy, right? We're dealing with a world of randomness, of kind of uncontrolled kind of manner, as we all know, right? We don't live in an ideal world. And so data can be changing, and you have to be, at any point in time, you have to be responding to the changes and being able to kind of deal with it, and then kind of tweak your model as you go along. So that's actually the as we all know, and I'm assuming all of you, most of you in the audience are machine learning folks, right? And you are all already familiar with the fact that machine learning isn't a simple thing, and it's basically you're dealing with data that keeps changing, and therefore you need to constantly be adapting to it in order to generate a model that makes sense. And then also too, you have to deploy it to production, and production too, you have to like keep updating because the data keeps changing with this entropy kind of concept of randomness, of keeping change all the time. So again too, I wanted to point out, right, the ingest data part is where I feel the streaming platform can come into play, because on a software engineering level, ingesting data is not a simple thing. It's got a lot of details to it. So that's where my talk to is actually, I'm not so much about generating your algorithms to meet with your data and how do you interpret it. It's more about ingesting this data, the mechanics of bringing the data into to be trained and all of these. So a bit more of the infrastructural thing. So that's where I come from. But I think this is a very good diagram to kind of explain, right, ML software, MLOps, and where it stands, and why do we want to bring in streaming kind of mechanism to do this work. So problems that ML model needs to solve, right, as we can see, there's also very often kind of slow and brittle and inconsistent deployment, right? It's because too is that if we have to deal with the data, and then if we're not doing it in real time, data is dynamic. If we don't do it in real time, the moment you kind of take the data, maybe perform a batch processing, at that point, if you deploy it, the data has already been changed, right? So machine learning model in general too, you need to solve this problem. It's slow and brittle, and data keeps changing. How do you deal with it? Deployment can be inconsistent, and then also too, a lack of reproducibility too. And you want to try to reproduce things, but your data already get changed and that type of stuff. So it's a lot of challenges when you're dealing with data that keeps changing as you are kind of trying to train your model. And then, of course, too, another big concern is with performance, right? So you're kind of doing training, serving, there's a lot of skill too, and there's performance concern too. You need to be waiting, you need to be this synchronous way of doing things. It's not ideal. Let's put it that way. So if you kind of look into this too, essentially, machine learning model is no longer just working with data at rest, right? If you kind of are into data, right, you know that there's data at rest, and then data in motion, and then also data in transit. Wait, what is it? Data at rest. Okay, rest is basically if they are in storage, right? Or kind of you pick it from the storage, you try to like process it. And then data in motion is when data is kind of like happening, right? And it doesn't kind of it isn't like directly dealing with persistent storages of your database, for example, things like that too. So, and then there's also another one is data in what is it? Like I keep forgetting about it. How can I be? Anyway, so yeah, so it's the data in motion. But we know too is that we are dealing with data in motion. It's what machine learning model needs to try to solve. So a word about data in motion too. So what is this data in motion? So basically, data is always moving across parts of the cloud and the system. That's kind of data in motion, right? It keeps moving. There's no, it's kind of restless. Think of it like that. And then at certain junctions too, the data itself can be transformed or being logged too. And benefits of architecting systems with dynamic data, though, is that, and here's the thing is I wanted to introduce like streaming platform, right? The benefits, what are the benefits? It helps to reduce latency, right? So otherwise too, if you kind of doing things a traditional way, you kind of expecting, okay, I have my code and I take the data as, batch them all up. And then, a lot of latency involved too. But the thing is, if we want to dynamically process it in a streaming type of processing capability, it reduces the latency. And it also helps too with higher interoperability. And then it's this kind of processing is very critical for today's cloud native systems and digital platforms, such as like financial fintech companies, internet companies, as we know, right? We're already kind of the world too is pushing us to go forward. We do need to kind of think of better ways of handling data in motion, especially with MLOps, the challenges in there. And then different services too in kind of doing streaming platform also is great is that the way it is designed is very loosely coupled. The reason, well, the explanation for loosely coupled meaning that you can be using Python. Most of the folks you're using Python to deal with your data, your runtime and everything. And maybe then you have your backend services. It can be in Java, it can be in, Go and other things that you may not be as familiar with, but you can essentially build up pipelines that they can all be in different flavors and runtime and all of these things. And that's the nice thing is being so loosely coupled and this kind of architecture approach, it allows all of them to still communicate, right, from one to the other. So that's kind of a really big advantage of using a streaming platform to help you with the MLOps type of work. Now, the thing is, though, it is like with challenges too, don't kind of get me wrong. So how do we work with fault tolerance, right? And buffering and back pressure. And that's the thing too, if you're kind of dealing with data in motion, you have to be worrying about those things because you can be, right? Back pressure, you can have tons of data all of a sudden comes all at once. You need to buffer it. You need to kind of slow it down or throttle it, all of these things. So you do need like a streaming platform that can guarantee that there's no kind of big back pressure built up, right? It control. So in a control manner, so then you don't need to you essentially your processes won't get choked, right, so to speak. And then also fault tolerance in a cloud native environment, especially that you need to also deal with fault tolerance too. You want to ensure that your components of processing all of your data be always up. This high resiliency, high recovery. If one components go down, another one will kind of come back up. And of course, too, these days when we deal with MLOps, we also bring in containers, right? And prime example is using Kubernetes, for example. And I'm also aware, right, of using like Kubeflow. All of these are kind of specific for building like machine learning kind of application, machine learning ops kind of application. So that's kind of data in motion in the ML ops space, the challenges, the benefits, all of these things. And now then, let's kind of move on, right, to the next part of this discussion. So I already kind of addressed some of the basics of MLOps and what are the needs and challenges. And now I want to introduce to you event streaming and distributed messaging. Maybe some kind of basic understanding would be helpful too, right? So event streaming processing, right? Okay, so now kind of put away the thoughts of machine learning. Just look at event streaming. But first of all, too, let's kind of look at it. I actually don't have that slide in here, but the thing is, too, with events, right? It is what we're trying to deal with. These are events, right? It's basically, what is it, right? So events, right, in a computing sense, is basically it's a data point that originate from a system that continuously creates data. That's an event, right? It generates some event, some occurrence. So then it has a data point, right? If on an XY coordinate, XYZ coordinate, right? Even like with another fourth dimension, which is the time component, you can have a data point, represents that data in that point in time. So that's an event, right? Is each data point in the system. Stream is basically refers to an ongoing delivery of these events. So now in very simple, like a research environment, we're dealing with events. We usually write code that are like maybe like one stream that dealing with events that happens as they come, maybe like just one stream of data. But in reality, right, say for example too, not just with machine learning, can be like Internet of Things, and and then of course too with machine learning, you can be collecting data from an IoT application. For example, like you're you have installed like different temperature gauge, in your farm, and you can have like hundreds of them all spread all over your fields, and you are doing temperature, because if the temperature goes up, then you want to be able to alert the farmer who's a user of the system and tell them, okay, you need to water, right? You want to keep water for certain crops needs to be like, on a certain level, things like that, right? So that is very important. So those are kind of events. And then streams are basically, you can have streams of data that's coming in, and they keep sending data, is collecting temperature data and keep sending it to the server. That's kind of stream, right? They are ongoing delivery of these events. They can have hundreds of them when you have 100 devices on your field, and they can be sending information every 5 minutes, let's say, or something. So as you can see, you can collect a lot of data, but that's event streaming kind of processing. So a series of events can basically be referring to streaming data or data streams, and that's what we're referring to. Now, there's also complex event processing. So complex event processing is a set of techniques for capturing and analyzing the streams of data as they arrive, right? And what's the purpose of that? Is to identify opportunities or threats in real time. Now, in a machine learning kind of capability, I'm sure you all know, we want to be able to do maybe like a shopping application. You want to predict, right, somebody's shopping based on their shopping behavior. You want to make certain recommendations. So you identify opportunities in there. So you employ a machine learning algorithms to constantly be monitoring the user's keystrokes of where he or she is clicking on. Then you want to immediately kind of identify, okay, they are trying to book rooms in Barcelona, for example, a hotel room. Then you want to immediately know that, and then being able to immediately make recommendations. And hey, how about if you stay in Hilton, versus staying in another, Marriott, something like that, right? So sort of that's really complex event processing. So essentially, too, complex event processing enables systems and applications to respond to events, to trends and patterns in the data as they happen. So I know there's a lot of like theory in here, but I just wanted to kind of point out to you what are events, right? How can it be helping machine learning operations too? So then there's also event-driven versus message-driven messaging. Perhaps you are like less concerned with that, but I still like to point out is that event-driven, essentially too, if you have worked with like Pulsar, right, publish, subscribe type of messaging mechanism too, event-driven essentially is emitting messages, and then interesting subscribers can subscribe to the messages. Now, there's also message-driven type of messaging systems. Basically, the sender and receiver is one-to-one. So then they know each other's address, right? I know that I will be talking with, like a receiver. I'm the sender, and I'll be sending it to a receiver. And I know it. And so the address is known. So that's kind of the differences. And perhaps you are less concerned with that, so I won't get into too much detail. Now, the thing is with event approach and versus batch processing. So why, right? So now we're kind of trying to advocate too for event approach, right? Not just for MLOps, but for many other things too. But because the world too used to be doing things in more batch processing fashion, right? And don't get me wrong, it is perfectly fine, right? Batch processing, there's nothing wrong. But there's also a lot of cases in which batch processing cannot address, right? For example, I talked about already about data, right? We need to deal with data that's kind of happening, data in motion, that's kind of very dynamic situation. You want to have fast response time, then batch processing won't do that for you. Like, for example, like you can be not only doing machine learning. You can be doing like a big company. They are processing changes, right, in certain kind of information. For example, a large financial company, it has all these transactions. Some of these, it needs to happen right away, but things, for example, like your subscriber, remember, sometimes too, as a subscriber, let's say you're a trader, or not just a trader, maybe in a bank account, right? You make certain kind of transaction. It takes a while for them to get through, right, to reflect it in your in your transaction record, because it's doing things in a batch processing format. It collects all of these activity during the day, and then at nighttime it processes it. So that's why it takes a long time. And sometimes it's okay, right? Not an issue. But the thing is, we live in a world that's kind of constantly, kind of evolving so fast, right? If you don't catch certain things, then your opportunity will be lost. So that's when we kind of want to consider using an event approach. And then there's also event messaging semantics and patterns too. Now, as such, just now I already mentioned about event-driven versus message-driven, so I won't get into too much detail, but just so you know, streaming too, we're kind of working with a pub-sub kind of like messaging kind of semantics, right? That kind of a manner and an approach. So there's always like publishing client. You basically is you send the data to a broker. It's kind of, think of it like the post office agent, right? You want to send messages. The publisher is like, okay, I have these messages to send out, but I don't know who gets it, and I don't really care. So let me kind of label these messages as give it a topic, give it a channel name, and then basically give it to the broker. And the broker is like, okay, you handle it for me. So the broker will manage these topics, these channels. And then whoever is interested in the topic, they don't actually know who sends it. Well, not exactly, but you can say that the subscribing client will then, if I'm interested in the topic, let's say call best movie, of May or something, then I subscribe to best movie in May, or the most viewed kind of movies in May, that particular topic, and I will receive the data when the data is available. Things like that, right? So just giving you an idea. And then there's also message queue too. Now, as such, message driven is sort of like a more message queuing kind of way of doing things. It's asynchronous, right? So that's kind of like the really good kind of way of doing things. Asynchronous too is service to service communication. And then it's used in serverless and microservices architecture. They are stored in the queue until they are processed and deleted. So as you can see, right, and without going into all of the details, I know our talk is less about messaging, but wanting to point out to you is that trust, this technology, the message queuing and PubSub, all of these things are to help you. So then it helps with scalability, right, of all of your messages coming in. It helps with back pressure. Some of the challenges that I talked about earlier about machine learning, for example, you're dealing with data in motion or those things, right, like fault tolerance, all of these things. In a streaming platform, it's ought to have already built-in capability of managing fault tolerance, buffering, back pressure, all of these things. So okay, so now why event streaming, and also why is it for MLOps, right? So what's driving the change, right? So basically, too, first of all, streaming is basically allows you to use real-time data to enhance your customer experiences and create a competitive advantage for your business. So that's kind of the primary goal. Everything is dynamic, really fast. It supports like data in motion. Things happen right away. You can immediately generate results pretty much, right? Kind of like near real time, put it that way. And then the second thing, as you can see too, is that it can be used, right, in data pipelines to build AI and machine learning and smart models from time series event streams. So that's where we wanted to kind of propose, is that using a streaming platform to help you with building a machine learning pipeline, machine ops is probably the way to go, this future. That's coming up, right? Because so far too, interestingly, when I was reading on some a report from only 2 years ago, 2020, there's apparently at that time was only 22% of companies, and that's actually successfully using streaming type of platform to help with real-time machine learning processing. So I believe there's still a lot of kind of opportunities in there to make this more of a norm rather than something that's difficult to do. So, okay. And then basically too, with a streaming platform too, it helps with scalability, right? There are demands of large volumes of data generated by the application operating at the edge. You use streaming platform, it's kind of poised to be very easy, or I should say like very easy, but more like, it's kind of able to handle data coming at you quite fast and all of these things too. So, All right. So again, why event streaming? So just kind of like a sums up, right? Watch for events with the system or application, right? Data in motion when we talk about data in MLOps. Subscribe to topics to see certain event types, right? And make decisions on data in real time. And that's kind of like the kind of like the thing, right? Make decisions on data, and on the data in real time and not after the event. Yeah. So that's the advantage. And it helps to ingest high frequency of messages with very low latency. So as you can see, right, that's one of the kind of things that's MLOps kind of bring to the table, is that it needs to be have the code and also ingesting high frequency of messages and keeps coming back and forth between you developing the model, deploying to production, and you come back and ingest more data like that. So examples of some streaming platforms in here. So a few popular streaming platforms, right? And I think most folks are probably already familiar with Apache Kafka, right? And it's an Apache project. And then there's also Apache Flink, right? And Apache Flume, a bunch of the Apache project, Apache Spark, and I didn't actually put it in here, but okay, there's also Spark, right? And Spark streaming, all of these, Apache Storm, all of these are kind of popular streaming platforms too, but they all kind of do the streaming kind of in their own slightly different way. But Apache Kafka too, it also has a managed cloud platform, right? On Confluent Cloud too, that you can do it. Now, outside of kind of open source and Apache, then there's also Google PubSub too that you can also employ to using like streaming on the Google PubSub. And then, of course, there's also Amazon Cloud that offers like AWS Kinesis, for example. These are more kind of serverless type of processing too. So these are a few kind of popular streaming platforms. Now, I just wanted to kind of spend the next maybe 5 minutes or so, right, and about newer. I shouldn't say like all new. On a new on kind of like a as I realized this streaming platform isn't as well known at this point, is because it comes a little bit later than the ones that I mentioned to you previously. So that's Apache Pulsar. And what is Apache Pulsar, right? So it is open source. It's an Apache project. It's created by Yahoo. And it got contributed to the Apache Software Foundation in 2016. And the thing is, because Yahoo too at first was trying to use Kafka or something similar to that, like a messaging platforms to handle large volumes of data that they work with, right? For example, in their various Yahoo services, like Yahoo Finances, Yahoo, you name it, right? Any kind of Yahoo kind of thing. And so they realized that, well, there's a bit of an issue in there because they are already into the cloud and doing all of these clustering, all of the cloud native. They realized that Apache Kafka might be not as easy to do. And the reason is, it's not like it can't do it, but it requires more work on the developer side to kind of manage the topics, right? Manage all of these things. And it's just overall, it's a bit more work, right? And so they thought of a new way. So they designed Apache Pulsar. And Pulsar is actually a truly kind of streaming platform that's kind of poised for the next generation of enterprise messaging. And how is it so? It's actually, I call it like it carries the cloud native DNA, right? It was actually born kind of after Kafka. They realized that Kafka couldn't handle it. It can handle, but just requires more work. Is, for example, right? You need to like increase your number of nodes, right, in your in your cluster to handle some of these topics. So as a result, then you will need to manually adjust, rebalance all of your topics that has been scattered on your different nodes, right? So those things, you can do it in Kafka, but it's not very easy. And every time you need to do things in Kafka, you need to pre-design, right? Kind of plan it, pre-plan, and how many topics you need, how many partitions, all of these things. You have to do it beforehand. And then after that, if you need to grow it, you need to rebalance by hand. And so it's more work. So they designed Pulsar. For example, Pulsar has this really is a big thing because then Pulsar has dynamically been able to handle all of these rebalancing of all of these topics for you and how they get scattered in different nodes on your cluster, things like that. So that's something I wanted to kind of quickly point out to you. That's the strength of Pulsar. Truly cloud native design, right? And became top level project in 2018 because people start to realize the value of Pulsar. Cluster based, also support like multi-tenancy, And it's simple client APIs too. It supports Java and also C Sharp, right? And Python and Go. So it's pretty flexible. And like I said, right, you have a streaming platform. You can write in different languages and still communicate with your topic, with your broker, all of these things. So it makes it easier. So you don't need to worry about, that I must learn certain languages, right? Things like that. So it is pretty flexible. And basically, too, it also separate out what is called the compute and also the storage. In any kind of messaging systems, it keeps logging, right? All of the messages that comes in. It's sort of a distributed logging kind of a system. So Pulsar itself, too, it doesn't manage it. It's basically delegate to another kind of library to handle it. So then it can focus on more of the messaging part. So that's also another advantage of it, too. And the nice thing about Pulsar is that as a messaging system, it guarantees message delivery. So if a message successfully reaches a broker, it will be delivered to its intending target. Now, we live in a world kind of entropy comes in, right? Things are random. Network is not reliable, all of these things. But Pulsar has this built-in capability to guarantee message delivery. Now, if you're familiar with messaging delivery, it has what is called QoS, right? Quality of service delivery. So it supports to like either you send the messages, you fire and forget, like 0, right? QoS 0. QoS 1 is like you can deliver to your destination, but you can have duplicate messages. I don't care. Just at least you deliver it once. And then there's also QoS 2, which is I want to deliver the messages exactly once, not more than once, right? Only one, and not 0, not more than one. So like this. So Pulsar has this kind of fine, kind of granular way of guaranteeing your message delivery. And then it also has what is called like a lightweight serverless functions framework. And that's where I believe that for MLOps too, you may also find it to be useful because you can basically transform the data as they come in before it gets kind of written up to the next stop in your data pipeline too. So I will kind of touch on it slightly in a subsequent slide. And also too, and it has a lot of kind of really nice kind of infrastructural kind of support, like for example the storage offloads, right? So you have data that's kind of living in your server, but then over time it becomes kind of stale, right? Not exactly all stale, but you want to move it off to cold storage. So Pulsar, you can configure it so it will move all of these data to long-term storage too when the data is aging out. So I just wanted to highlight too, Pulsar has a lot of benefits of being a streaming platform that kind of handles a lot of these otherwise would be tedious thing that as developers we don't want to deal with, especially with machine learning. You want to spend more time on working with your machine learning algorithms. You want to fine-tune your training model and all of these things. So all of these infrastructural things, you leave it up to the the platform itself to kind of handle it. And again, what is Pulsar, right? So it's a unified distributed messaging and streaming platform. And it's open source, right? Originally developed at Yahoo, contributed to ASF, the Apache Software Foundation, in 2016, became a top-level project in 2018. Very much supporting cloud native. It was born in the cloud native times, carry with it the cloud native DNA. And supports Kubernetes. You can run on multi-cloud or hybrid cloud, on even on-premise too, if you don't want to change what you already have. Some people, for example, you're doing things like in JMS, you can still run it and you can essentially plug Pulsar on top too. So as you can see over here too, a couple kind of graphs too, just wanting to show you, it's not a joke, right? As you can see, between 2017, the time it became 2018 became a top level project, the number of GitHub stars have increased, contributors have increased, and even monthly active contributors also has surpassed Apache Kafka too, because people are recognizing it being the streaming platform of the new age time, so to speak. Okay, so who else is using Pulsar, right? You might be wondering. So all of these big companies, Comcast, Yahoo, Verizon, right, and Splunk, all of these, right? So it's not like, unproven. It's proven. It's been used in production these days. So Pulsar is different. Again, just a kind of very quick thing, right? There's producer, consumer, broker, and then there's also, it relies on what is called it uses Apache Bookkeeper, another open source project, to manage all of these distributed logs. So then you don't have to worry about managing all of the logs. You don't have to manage about rebalancing. Pulsar itself already manages for you. It has the broker that interacts with the bookkeeper, everything. So you don't need to worry about it. And then it also makes use of Zookeeper. Zookeeper is essentially, kind of think of it more like a managing library. It manages things in a cluster, the metadata, the coordination task between the different clusters in your cloud environment, for example. So design principle is a tiered architecture design, right? And I already described producer and consumer. And they send messages over to the broker. Broker will be serving them. But then on the other hand, producer, consumer not have to worry about any of the data, because then the broker will be handling them and dealing with all of the storage, the topic partition, everything. And it interacts with the bookkeeper to kind of handle all of the bookkeeper storage of all of these log messages too. So, okay, so I won't get into all of these details because these are more specific to Pulsar things. So over here too, again, the multi-node architecture. And then you might be asking, what's the big deal? The point is that it's very fast. It's low impact and horizontal scaling. And I won't, get into too much of this detail, but if you're interested, I will be very happy to share with you more about the bookkeeper specific and broker too. And then again, Apache Pulsar solves the problem of bolt-on, right? So it's basically, it helps you pops up with queuing, with streaming, with message mediation and enrichment too. So it supports like cloud, on-premise, and hybrid. And it also has this feature called geo-replication, multi-region support, data lake integration, all of these things too. It may not be what you need right now, but it might be something you may need in the future, especially when you're dealing with companies, across different regions of the world. All of these things will come in very handy, trust me. So okay, so here too, how is Pulsar different? So the next generation architecture will provide distributed tiered architecture, and it separates the compute from storage. It has Zookeeper that holds the metadata for the cluster, and it has stateless broker that handles producers and consumers, the sending and receiving part of messages. And the storage is basically of these distributed log messages are handled by Apache Bookkeeper. Okay, so just a very rich system of connectors and clients, and they are very nice. They're loosely coupled. You can be talking to one another without any issue. And okay, so these are just tier differentiator. And because I don't have as much time, so I won't kind of get through, because I already mentioned about flexible message processing, all of these. If you're interested, again, I can help you with that too. Now, the thing is too, I wanted to point out machine learning in Pulsar using functions. So as I mentioned earlier too, Pulsar has kind of many kind of capability, one of which is called Pulsar functions. Think of it like serverless functions. You can write these as serverless functions, and they can be used to provide near real-time machine learning. And it's for developing and maintaining the collection of inputs required by machine learning model to provide a prediction. And you can execute any PMML. Like PMML is your machine learning specification, right? It supports those models inside a Pulsar function. And you can also execute non-PMML models inside a Pulsar function too. So those might be something that you are interested in checking too. And data stacks, right? We have Pulsar. So basically, data stacks, we have what we call Astra streaming. It's a managed Pulsar. And then there's also Luna streaming, which is actually, okay, Astra streaming, it gives you a $25 US dollar as a credit, as a starter. And you are all welcome to sign up. I'll give you the link so you can sign up for it. And then there's Luna streaming, which is open source. You manage things on the cloud yourself, but you can purchase enterprise support. Or if you are all interested in open source, you can use the community-driven Pulsar to help with your project too. Okay, so these are just different examples. Again, kind of explaining Astra streaming versus Luna streaming. If you're interested in Astra streaming, we're still seeking like early access participants too. So please do let me know if you're interested. Okay, so basically, I don't want to be comparing so much now, but let's kind of really quick demo part. I wanted to just quickly show you, right? As I kind of mentioned, you can actually do this. Go to astra.datastacks.com. Again, it is in my slides. And basically, you can then, you can create an account. It doesn't require a credit card right off the bat. But if you're interested in additional $200 credit, there's actually a code which I've supplied for you on this slide deck too. So as you can see, you can actually quickly over here, you can take a look, right? Again, AstraDB is managed Cassandra in the cloud by DataStax. And then if you want to create streaming, you can actually go and create streaming tenant too. I won't kind of do it now, but I just, again, wanting to show you, right? You can kind of create, actually over here, you can create different organization too. I separate out this because this is a project I recently helped out. And I basically create a a tenant, right? And then you can then do how do you connect all of these? I think using this console is very, very helpful. This is kind of taking a bit of time. But otherwise, too, I wanted to, yeah, there we go. So just wanted to show you, right? You create that streaming, the tenant and everything. And how do you connect to it is this. Everything, I think, is laid out quite easily for you. If you want to write in Connect using a Java client, Python, for example, all of these kind of gives you example of how do you do it too. And how do you create topics, right? It's over here. It's a little slow. So over here too, for example, I already have 2 topics in here, for example. So you can quickly create topics. You can send messages and all of these things too. There are also namespaces, and basically namespaces are kind of, think of it more like a unit of identification within a complex cloud native type of deployment. And it kind of identifies that particular unit of operation for that particular use, right? So, and then I mentioned about Pulsar function. So you can actually also like create a new function and it will guide you through here too. And then there you build out data pipelines and you can create what is called a sink, right? You have data pipeline, a source, and then a sink, a source and destination. You link up again, and that destination become a source and then send to another sink too. This type of stuff, it's also all here. And there are sources, and then it also lets you try this yourself too. This particular, kind of WebSocket, you can try this out your topic too and test it out. So again, this is just a very quick example that what you can do with Astra database, and then trying out the Astra streaming too. Okay, so let me get back. So now, where to go from here? And please keep in touch. This is where you can find more information about Pulsar, about Bookkeeper, Zookeeper, all of these are Apache project. And then in DataStax side, we have extra.datastax.com. That's the cloud that I was just showing you, the managed Cassandra cloud. And then if you want to know more about Astra streaming is here, and Luna streaming. And then CDC is a change data capture. So if you're interested in that too, it will kind of detect changes for you and do all of the automatic updating for you too. So again, if you're interested, I have a separate talk for it, and I will be happy to help you too. And AstraDB, as I mentioned, right, you can go to extra.datastax.com to sign up for a free $25 per month, right, credit. It keeps renewing every month for you. If you're interested in additional $200 US dollar in credit, you can use open source 200 code and visit this link in order to get to that too. And follow me on my Twitch stream every Wednesday. Usually, yesterday I wasn't feeling good, so I couldn't do it. But otherwise, too, whenever I can, I have Wednesday at 2 p.m. US Central Time. I have my Twitch stream. So please follow me there. You can ask questions and everything. And also, too, for our Pulsar, we have a meetup group that we're starting, Apache Pulsar Neighborhood. Also, another like wiki page called Apache Pulsar Neighborhood, too. We encourage everybody to come in. If you're doing machine learning, we love to hear about your experiences and pass on your input back to the engineering for improvement, too. With that, I want to thank you all. And I think I'm like a minute or so over time. So thank you. If you want to get a hold of me, this is how you can get a hold of me. My LinkedIn profile, my Twitter, and also a Discord server. You can connect with me on my Discord too. So thank you. Oh, okay. Thank you, Rustam. Rustam was saying that it's okay. So thank you. And I'm kind of looking over there at the YouTube channel. I don't recognize any questions. So yeah. Anyway, so yeah. If folks are reading, if you're watching this on demand too, yeah, feel free to reach out to me on Discord, follow me on Twitter, send me direct messages. I'll be very happy to answer any questions which you may have. And again, thank you so much to Confer. Thank you very much to Rustam and the organizing team. This has been wonderful. I really enjoy it. And thank you.